the reversed items replace what they reversed. So if you had 10 items to start, you should have 10 items when you finish. The reverse scored one should just sub in place of the regular one. So if you have a reverse 7, your regular 7 should not be included in this. Okay, so we did this. It says alpha, which is number 5. You're going to click on the statistics button. In descriptives 4, you click on the boxes next to item scale and scale item if deleted. In enter item, you click the box next to correlations, and then you hit continue, and okay. Now I just put in random answers for this scale, so I might have a really wacky alpha here, and I do. My alpha is 0.18, which is not good. So let's answer the questions now. Here's our output. So first, these are questions 1 through 5. What is the coefficient alpha? You find that right in the reliability statistics box. So we have Cronbach's alpha, and you look right there, 0.18. Is it equal to or greater than 0.7? Mine is very much lower than. If not, would your alpha be increased to exceed 0.7 if one or more items was removed? So if your alpha is greater than 0.7, you do not need to answer 3, 4, and 5. If it's already greater than that, just put NA. Mine is less than, so I need to answer this. So how you figure that out is there's this in item total statistics. It tells you the scale, the Cronbach's alpha, if the item was deleted. So we have 5 items, and it's saying if item 1 was deleted, your alpha would be a negative 0.6. Again, you shouldn't have negative Cronbach's alphas, but I randomly input stuff, so the scale doesn't make very much sense. But I just want to tell you how to read it. So for example, it's telling me for reverse 5, if I deleted that item, my scale would go up to 0.76. So that's really good. So maybe I should get rid of that reverse scored item because the scale would go up a lot. So if so, which one? Reverse variable 5. And then is there anything about the way the item is written that makes it different than the other items in that scale? This one is basically just asking you, why do you think the scale would be so much better if you took that item out? Do you think it's badly written? Do you think it's confusing? Do you think it's not measuring the same thing the others are? Just give an answer about why one item seems to be so much worse than the rest. And now we have step 3, how to create composite scale scores for your scale. So we go to transform, this pull down menu right here, and then compute variable. Move this over here. In the box labeled target variable, which is right here, I'm going to type the name of the scale. So let's say my name is animal scale. I don't know why it would be, but let's just say. In the box labeled numeric expression, which is right here, you include the equation for taking an average. You click on the parentheses, and you add together all the items on the scale. So I'm not going to include reverse item 5 or item 5 because I just said in the last question that if I remove that scale, the alpha would be a lot better. So we're just going to drop it. And that's the this B right here, 4B. So you add together all the items on the scale. So V1 plus V2 plus V3 plus V4, and that's it. And then you divide by 4, because we have 4 items in the scale. If you have 10 items, you divide by 10. We're just taking an average here. And then click OK. And so it's telling you it did that. And if we go to our data set, we will see that we now have a variable for the scale. So this person scored a 1.75 on the scale, a 2.5, a 1.5, a 4, and a 2.5. So that is the assignment. You're going to do that by yourself. And like I said, this sheet will be in the assignments sheets modules. I'll upload it after I post this video. So we did that. We are now, let me close out of all these windows I'm in. Close, close, close. All right. We are now going to move on to factorial designs. I just want to start this out by saying that factorial designs are tricky and they do take some getting used to. But you can do it. It's doable for sure. I just want to give everybody a little bit of leeway and maybe be a little nice to yourself. If it takes a minute to click, it will click, but it's just tricky at first. So learning to interpret factorial designs is important for two reasons. Firstly, it's a part of exam 2, but secondly, you need to use a factorial design if you're proposing an experiment in your final research paper. And to do well with this topic, we're going to become familiar with the concept of interaction and moderation. We went over moderation a couple weeks ago, and also using graphing as a tool for understanding interactions. Looking at graphs is a really easy way to understand interactions, way easier than looking at a table. So, factorial designs. Factorial design is 2 or more independent variables with all combination of levels. So, for example, if we just had 2 independent variables, it would be IV1, IV2, and our dependent variable. An interaction means that the effect of one independent variable depends on the level of another independent variable. There's moderation if you have an interaction and vice versa. So there is interaction if you have moderation, there's moderation if you have an interaction. That's what I meant by that. Now, if we recall Lab 8 slides, I'm going to pull them up right here. There is a lot of information on moderators and a lot of examples. We went over tons of examples together. So if you needed some extra examples, feel free to go back to Lab 8. Hang on, I need to go close my door. My cat just walked in. Excuse me, guys. Okay, I'm back. So go back to Lab 8 if that is helpful to you. Go back to our lab slides. Okay. Factorial designs are also needed when you expect there to be an interaction. So if you're proposing a hypothesis, for example, I think more sleep will lead to more happiness, but only for people who aren't depressed. If that's your hypothesis, you need a factorial design, because a factorial design is how you test that. So, factorial designs are described with a specific notation. You'll also need to know this notation. So, the notation is the levels of IV1 by the levels of IV2. So for example, a 2 by 2 factorial design means that IV1 has 2 levels and IV2 has 2 levels. If we had ice cream, vanilla, chocolate, and strawberry by season, winter or spring experiment, the notation would be 3 by 2. It would be 3 by 2 because variable 1, represented right here, has 3 levels, vanilla, chocolate, and strawberry. And variable 2, which is represented right here, has 2 levels, which is winter or spring. So moving on in factorial designs, there are potential effects of factorial designs which you need to know all the possibilities of. So first of all, each independent variable can have a main effect. Then you can have an interaction between the 2 independent variables. So a design with IV1 and IV2, which would be maybe a 2 by 2, maybe a 3 by 2, for example, has 3 possible effects. First of all, main effect of IV1, main effect of IV2, and then an interaction of IV1 and IV2. So we're going to go over 2 examples on in-lab assignment 7. Like I said, it's due next lab, which is April 1st at midnight. I do want to say these examples don't include any statistics, so please assume any differences are, in fact, statistically different. So let me pull up the assignment real quick just so you can see what it looks like, and then we will go over it. That's not it. Here's the assignment right here. I've copy and pasted everything, so what we're going over is exactly what's on the sheet. 1 and 2 already have the answers written out, which is why we are going over them, and there's up to 6 questions. So, TV viewing and social consciousness is number 1. The question: a psychologist was interested in the effects of television viewing on social consciousness. College students agreed to be assigned to groups identified by 2 independent variables. A, 1 versus 5 hours of TV viewing per week, and B, only PBS TV viewing versus only reality TV viewing. The dependent variable was social awareness, as measured by a questionnaire. The questionnaire was scored 0 to 100, where 0 indicates low social awareness and 100 indicates high social awareness. So, this is the first example. We first want to identify the type of design. So this is a 2 by 2. There's two variables, which is why we have one placeholder here and one placeholder